Hey everybody, we're gonna get started. Tonight's topic is on Fixity and BagIt. So just a couple of things. We are recording this webinar. We'll do a Q&A at the end, so just hold everything hold any questions to the end. We don't have a chat tonight. And then just please stay muted. We are kind of a large group, so just keep your microphone off tonight. And if you haven't joined us before, Backlog is the name of the company that we put on these webinars. We do one webinar every month. This summer we're doing two a month. And so Backlog is an archival consulting business. We do archival needs assessments, policy writing, and then we can work on some digitization plans, kind of picking out how to digitize and then what to prioritize. And I'm Emma. Backlog is my company. I founded it in 2021 during the pandemic. And I'm joined here tonight with Sarah, who's our presenter, and I'll let her take it from here.
Hi, everyone. I'm happy to be here. Happy to see you all here. So I wear a few hats. I work for Backlog and I also work for WashU, where I focus on web and email archiving. Another hat, I volunteer at the National Building Arts Center, which if you might be interested in a different kind of archive, where they collect historic salvaged building artifacts and large grand building facades in a giant warehouse campus, you might check that out, nationalbuildingarts.org. Next slide, please. So we're here to talk about Fixity and BagIt, but I'm going to start with Fixity. So we need to really establish what Fixity is. So dictionary definition, it's the quality or state of being fixed or stable, fastness, fixedness, secureness, and from a digital preservation standpoint, it's that secureness, the security that we're really going for. When we're talking about fixity, that is well under the umbrella of digital preservation. When we're preserving digital items, anything digital, we need to make sure that it remains unchanged. If we want it to last nothing digital lasts forever, but if we want it to last as long as possibly can and be the best stewards that we can be of any digital object or file, fixity is the foundation of that. So you really cannot do digital preservation without fixity. Next slide, please. And how do we get there? How do we achieve fixity? There's really one way to do it. You generate a checksum. Have you heard about checksum? I think it's a little bit of an odd word, but it's definitely doable, whether you're trying to preserve your own personal stuff, whether you work for a small organization or a large organization. It's something that anybody can do. So you take your file, literally any file, run it through a program, and it will spit out like a code saying, I have assessed the status of everything in this document, whether it's a Word document or an image or whatever. And so that code that it spits out serves as a digital fingerprint. Check that digital fingerprint later on that same file, and it'll tell you whether that file is in trouble or whether it's the same file or whether it's being appropriately preserved. And you can do it by various methods. There's a bunch of different tools to do it. One of them is BagIt. Next slide, please. So, relationship between Fixity and BagIt. Why are we talking about both of those things in this webinar? Because they are distinct from each other. So the big thing they have in common is they are both about preservation of digital content, digital stuff, any digital stuff. BagIt is a way to organize and package up files, but its main concern is the security of those files. So it utilizes Fixity. So if you're using BagIt, Fixity is something that's just kind of happening through your use of BagIt, but you don't have to use BagIt if you want to enact Fixity on your files. You can use a bunch of other different tools, which I'll get into if you're concerned about Fixity as well. So that's their relationship. Next slide, please. Okay, digital content. We're going to take a few steps back before we go forward. When we talk about digital content, what is that? A lot of times people will talk about, like, especially if you're dealing with not just like a Word document, um, something like a digital repository or a database. They might be called a digital object. It might be called an information package. Um, and those things can have some difference, but when we're talking about how to preserve them, how to run Fixity on them, um, for the purposes of this webinar, this perspective, digital preservation, they're all kind of the same thing. Like digital object is not some fancy thing. It's just a file. These are all different ways of saying file. So whether it's text, image, audio, or video, they're all a bunch of data stored in a place identified by a name. Next slide, please. And then to get a little bit peel back one more layer, a digital object or digital content, what is it? It's a set of instructions for future interactions. So I've got this Word document on my desktop, and if I'm not opening it with Microsoft Word or maybe putting it into like Google Docs or something, um, it's not enacting its interactions. It's not performing its job. It's just kind of sitting there. So it's a little bit different from like a book on a shelf, like a paper book on a shelf. It's still very much a book, whether I get it down and read it or not. It, actually, no, you could say that the the paper book sitting on the shelf is um, those characters on the page, those words that we can read. Those are instructions. They're instructions. I take that book off the shelf later, open it up, start reading. I'm introduced to new ideas. So that's the future interaction. And as far as digital content goes, if we're gonna if we're gonna enact some of those future interactions, like we might hit Control P and print the document, or do any number of other future interaction, we might highlight something and cut it or paste it. That is dependent on a bunch of other technical components that are kind of surrounding. So you can't utilize your Word document unless you've got a copy of Word, or you've got another way to read it, unless you've got a computer or maybe a phone to look at it. Next slide, please. So these numerous technical components, they all kind of have to be in place. Um, this is an image that my colleague, the digital archivist at WashU, created, and I really thought I liked how it explained things. So um, take that center image, the files, those separate colored icons. That's maybe what we're most used to seeing, like on our desktop or on our computers. Those are the units of storage. And then to the left, that's the bit stream. What is in those files is actually just the zeros and ones, the bit streams. And that's how the information is stored. And then if we go to use it to sort of catalyze the use of those files, interpret those ones and zeros so a human can read it, then it becomes the digital content. Then the file is being interpreted by the software. And then we're like, I'm cooking, I'm doing my stuff, I'm, accomplishing digital tasks and functions, creating content, looking at pictures, doing whatever I'm doing. So all of those have to be in place, really. Um, Next slide, please. Okay, so we're going to talk about bits. Um, Bits are those ones and zeros, and they are at their most basic level, to get a little abstract. They're electrical signals or light pulses. That's really what they are. And they're in a binary configuration. So like a light switch, it can be either on or off, true or false. Um, and you can see there's a string on this slide of a bit stream, a stream of those bits. Each one or each zero is a bit, and you put them all together, they're in a stream. Um, that series of ones and zeros might be a word. I don't know what that word is. They're not easily readable by humans. So we're going to need some help turning this into content that we can read and utilize and change and adjust and preserve. But fun fact, it's bit is a portmanteau of binary digit. So put binary together with digit, you've got bit. Next slide. Okay, moving up from bits, here's kind of what I was just talking about, but each byte has 8 bits in it. You can see the bit is just one thing, and then you put eight together. That curly bracket along the bottom is showing you that's a byte. And we are a little bit more used to thinking about bytes like megabytes or gigabytes, how we assess the size of a document. We're assessing the number of ones and zeros, really. Next slide. Now this image, you might not be able to read all of it, but you can kind of tell there's a bit stream in the middle. So this series of ones and zeros, which I cannot read, it's got a curly bracket again in the middle on the top and the bottom showing, calling out eight of those bits. And then the arrows going in different directions show you that depending on what system you're in, um, those eight bits might be read as any number of things. An integer, a character, or even an image or a sound. So, depending on the file, the program, the software, a bit stream can become anything that you've got on your computer. Next slide, please. Okay, so this gets into the preservation part, and why we need checksums, because those bits will rot. Um, this is my like super gloom and doom slide. Yeah, it's not the most fun to talk about. Um, there are aspects of digital preservation that I tend to think of as kind of like going to the dentist, right? Or taking your car to the mechanic. Um, I wouldn't go to the dentist if I didn't have it established as part of my life and know very much how important it is and how things would go very, very wrong if I didn't go. Same with taking your car to the mechanic. People don't love doing it, but they love having done it and they love knowing that their car is in decent enough shape. So uh, any file, every file is susceptible to bit rot when a file gets corrupted or doesn't work anymore, or maybe you used floppy disks in the 80s and those don't work anymore and they're corrupted. That is bit rot. All of this is bit rot. Anytime a file gets corrupted, it's at base, we might call it any number of other things, but it's bit rot. Um, there are three kind of categories of ways that we hold things on computers. There's magnetic, which is tapes. Like if you put something in the cloud and it's stored on a server like Google Drive or iCloud or Dropbox or Box, those are located on the cloud is really servers, and servers are most likely some kind of hard drive, most likely tapes, and that's magnetic. Flash-based, most common example of that would be a flash drive, and then optical, CDs, DVDs, CD-ROMs, read by lasers. Those are an optical medium, but all of those are susceptible to bit rot. Next slide, please. So more about how exactly the bit rot occurs in each of these types of computer storage. Another gloom and doom slide, the magnetic fields weaken, becomes less magnetic over time. Magnets do not necessarily stay magnetic forever. As far as those CDs or DVDs, they're vulnerable to oxygen. We live in an environment with oxygen. And there are reflective layers to be read by those lasers, and those layers oxidize over time. A CD is not built to last forever. And in flash-based storage, the electrical charges gradually leak out, which sounds very alarming. Next slide, please. So there's things, on a long enough timeline, bit rot will happen. Hopefully that timeline is quite long for many of the storage media that we use in our typical lives. Storage gets better and better all the time, but we're humans, and we do play a role. So we need to do things like take care. Is this something that I'm doing frequent reading and writing on the media? Maybe save a copy somewhere else in case the copy that I use day to day, frequent access, something goes wrong with it. Software bugs. Um, if you work for a large organization, you won't be able to install your own software because they don't want just anybody's software on there. It might have bugs that will destroy files. If you've got a phone, you can't just install any old software. You've got to go to the software store for Android or the Apple Store to buy software. Um, Hardware malfunctions. Your hard drive might stop working, or your computer might crash. The physical computer might get broken. And then the particular human intervention, if you save a backup of your stuff on an external hard drive, please don't put that hard drive in your attic or your basement. That's after all of this gloom and doom, that's kind of sounding like the most easy thing that you can do. Like, just keep it in your regular living space. Next slide. Okay, here is an example of a corrupted file. This is bitrot. This is what happens when those ones and zeros flip. Friends enjoying a bonfire on the left, and then this image happens on the right. And there's no coming back from this. This is why with digital preservation, we need to run checksums on our items as a way of just like having that fire. It's not really like a fire, having a fire extinguisher handy. It's more like a fire alarm. If we run our checksums every year on the items that we care about the most, our kind of most archival items, we can know whether they're still in good shape or not, or whether we need to go to our backup, or whether we like, oh gosh, the AC was out and it got super hot in here, and that's why all these hard drives got corrupted. It's just a way of checking in with your files and making sure that they don't all look like this. No, and learning if they do look like this, that you can take some action and being prepared to take that action. Next slide. Okay, we're gonna move into BagIt. Before we get into like the check something, we're gonna cover BagIt first because BagIt is a great sort of like entry level thing. It is a hierarchical file packaging format. If you've used a zip file, like say somebody sends you an email and they've attached like 4 images, your email program might have zipped them, so you have to download them, double click them. You may have to use a zip program to unzip them, but most likely these days you just have to double click it and they unzip, and then you can look at each individual image or file. It's kind of like that. It packages them together and it is hierarchical. So it's extremely good if you work in an archive and you are tasked with arrangement and description. You want certain files, files from one donor, and they have to stay in order and they have to stay in their arrangement. So connected to the idea of provenance and original order, BagIt supports that quite well. What does BagIt consist of? It consists of a payload, which is your stuff, and then tags, which is where BagIt comes in and uh, does the checksums, attaches them to the payload, and then packages it all up for you and just provides a level of safety. One thing we love about BagIt is it is open source. It's not proprietary, so you can use it on any computer, and it won't be like, oh, I don't have a subscription to this anymore. I can't access it. So that in and of itself, also something we love in digital preservation. Things that are not proprietary, they will have that longevity. Next slide. Okay, so more about BagIt. You can see here there's an external hard drive attached to a laptop. If you're doing anything like that, I would recommend BagIt. You can put any kinds of files in it. If you're exporting from one program to another, moving from one computer to another. Um, if you work for a larger organization, maybe you have some items that are being transferred to another repository. BagIt would be Harvard, a guy, I'll talk about this in a minute, but a guy who was, they were transferring some files. They were web archive files, which is how I found out about it, to another institution. They use BagIt. So that's how it originated. Next slide. So more about BagIt and how it came to be and why it's good. I just thought it was kind of interesting to nerd out about this for a second. Yeah, John Kunz, he is a legend in the field of digital archiving. Um, he was working at the California Digital Library and wanted to transfer a bunch of files and just to find the best way to do it. So John Kunz, standardization. So right? Apple really cares what software you put on your phone or your computer. Um, it's people like John Kunz who, uh, back in the early days of computing, were making it so that this standardization happened. He has written software tools that come pre-installed with Mac computers to this day. He contributed heavily to the first standards of URL. So the fact that if somebody sends you a URL, you can open it on your phone, on your computer, on Firefox, on Chrome, on Netscape Navigator if you want, and it's all going to show you the same stuff. That's due to standardization. So as a digital preservationist, big fan of standardization. It's really just so fundamental to making things work. So he sort of created this concept, the enclose and deposit method, and referred to in sort of a colloquial, fun shorthand, bag it and tag it. Next slide, please. Again, two things in the bag, payload and tag files. So the payload comes again in that hierarchy that's going to remain the same no matter what. It's gonna be faithful to your organization, and the payload is the content. And then the tag files, a little bit more about the tag files. A manifest, so that's like if you're putting things in a box and you write out an inventory, put that on a piece of paper, put that in the box with the actual stuff. That's the manifest. That's also where the checksums live that BagIt just creates as a matter of course. Um, and also a file saying how this was done, what version of BagIt was used, and so on like that. Next slide, please. I really enjoy seeing a visual representation of this. So if anybody else is that way, here's what that looks like. Number one, starting with file, just regular files, PDFs, Excels, movies, whatever it is, you put it in a directory, arrange it in some way, then you create a tag. So the stuff is the yellow, the tags are the pink, and then you put it in the bag. So that's when BagIt accomplishes its software magic. And then the tag files are kind of sitting on the outside of that data with the checksums. Next slide, please. Here's another representation. If you're doing this command line, it would look like the version on the left, just plain text. And if you are using anything with Windows, it would look more like on the right. So you could navigate through the hierarchy just like you would on a regular computer. And there's your kind of about or readme or text files accompanying your stuff. Next slide. Okay, so we know with BagIt where the checksums live. What is a checksum? So it's a given bitstream, which is your bitstream is your Word document or your image or your movie. Um, and it's fed into an algorithm. That's the program, whether it's BagIt or another checksum generator. And it, as its action, as its function or purpose, it generates a string of characters that is unique. That's the digital fingerprint. And we save that digital fingerprint with the item and look at it later to see whether it's changed. Most common, they have these names like MD5 or SHA1, and you look at the checksum again later and you see whether those bits have flipped, whether those electrical impulses have changed or degraded or gotten less magnetized or been corrupted. And you can also see whether your file is exactly the same. So save a Word document, put it on a hard drive, put it in your closet, check it later, compare it to the file that you have currently on your computer, run it through your checksum software, and it'll tell you exactly the same, just so you can just feel assured that digital preservation is going well for you. Next slide, please. Here's what that looks like. So our item here, our content, our stuff, is this picture of a cat. And somebody ran it through a few different checksum generators. One of them is called MD5, and then they use the SHA1 and then the SHA256. And those strings afterwards, those are the checksums themselves. And there's kind of coding involved, but it's a little bit more, I won't say it's like human readable. We can't read it the way we read like words in human language, but when you're in your checksum program, it'll show you this string of the 16 characters utilizing A through F and 0 through 9, and it'll compare to your previous one where you ran the checksum, compare it to current day, and it'll highlight for you. You don't have to like go from one to one and be like, okay, it's 6D5B. It'll highlight for you if one of those characters has changed. Next slide. So if you're like, I am not moving files around, I am not concerned with hierarchy, I don't think BagIt is for me, you can utilize one of these programs to run checksums on anything that you have in any computing environment. If you work for a large organization, you're just the chances are this is being done for you by your digital preservation folks. Um, and if you're maybe you work for a medium organization and you're not quite sure if it's getting done, you might talk to some folks and say like, I've heard about checksums, and I have the names of some things that we could try. Do we want to look into that? Just to, we've got an extra hard drive of the same, our most precious content in the closet, but also here's another way we can kind of just enhance our digital preservation practices. Next slide. So, we did a webinar recently, a backlog webinar about premise, which is a metadata standard. You may have heard of Dublin Core. It's a way to attach tags or keywords to your content. Premise would be the metadata standard that would support preservation activities, all different ways to support preservation. And we don't like our files getting ruined. So, it's good to kind of look into these once in a while. Sit down, take a minute, schedule some ways out on your calendar and go, I'm going to sit down and think about it. I'm going to sit down and think about like, do I have all my stuff on my hard drive? Where is my hard drive? Do I like my cloud provider? Do I want to pay the 99 cents to Google or Apple just for that peace of mind? Um, if you're working with items that are in a repository or in a database or a large collection that goes with an organization, you might want to look into utilizing Premise. Um, and this is just a slide to kind of note the interaction with Premise and checksums, part of establishing the chain of custody. Next slide, please. Okay, if you're like, this is all super new to me and I would like more help. And I would like to see maybe some demonstrations, maybe something visual, maybe hear a little bit more. I'm just giving a really basic overview today. So for my last few slides, I really want to talk about the Digital Preservation Coalition. Their URL is dpconline.org. When we send you this recording afterwards, or if you watch it on YouTube, you'll see this URL and a few URLs in the notes below. If you are new to digital archiving or digital preservation, I highly recommend checking them out. They are a professional organization. They're in the UK, but everything works if you're in the US and I'm pretty sure many other countries. I go to conferences kind of all over the world, and DPC is always there. They're fantastic folks. This digital preservation handbook is aimed at an audience that is um, not expert. Okay, not expert. If you're thinking that is me, check out the Digital Preservation Handbook. They also have a course called Novice to Know-How. If you want to learn about digital preservation, it's free and it's very like visually oriented and kind of easy to get through. But if you're like, how else can I do fixums and checksums checksums and Fixity? They will show you a few of them. Here's a tool demo right here. Next slide. They will show you things like this. Here's kind of a grid or a matrix that will show you the results of, like if I were to try to use Fixity Pro, what might I get? Is the file present? Is the checksum the same? Is it the same file path? Oh, the file is changed. Here's your alert. Time to take some action. So this is a little bit kind of just an example of what you would be kind of working with as if you were engaging with these kinds of actions. Next slide. This is not a video. I'm not trying to play a video, but I wanted you to know that you can just watch a YouTube explaining more about how to create checksums for any content that you have responsibility for. That might be it. Next slide. Oh, yes. Okay. So 1998, this was a digital practitioner, and we'll have a shout out to RJ Morris in the notes afterwards. But you may have had an experience of, your computer doesn't work. And so you take it to Best Buy and they're able to find it. So after all of this gloom and doom, all of this, like, it's just like going to the mechanic, you've got to do it, you got to take care of all your stuff. I just wanted to leave you with a little bit of a glimmer of hope. When disks become unreadable, sometimes there is a way to recover that information. This was 1998 when this quote came around. I just love this word, a band of e-paleographers. I don't think they kind of go by that name nowadays, but we kind of have those people. So, as you are inhabiting the world of digital preservation, yeah, just wanted to kind of give you a little bit of hope. If you kind of do your due diligence, do even just kind of a basic level of digital preservation. Um, Make that appointment with yourself, sit down, do a little bit of an assessment. What am I comfortable with? Make that decision for yourself. And hopefully, if you do have problems, the e-paleographers will be around to help you out. Um, yeah, that's all I've got. So I'm going to pass it back over to Emma.
We've just got a couple of things and then we'll do a Q&A. So our next webinar is in 2 weeks. It's on DAX. Jenna will do that one, and then Sarah's back for another digital preservation webinar at the end of August. And then we're going to do more product, less process in early September. And then again, like we record our webinars and we post all of them to our YouTube channel if you want to take a look. And we've got a little bit of time for questions. So if you have a question, we don't have a chat tonight, so you do have to unmute. You can go ahead, and we're a smaller group tonight. Oh, we've got somebody with their hand up. Hi, Hannah.
Just what was just for the Q&A, so I can wait, or is that now? Sorry.
We're there. We're there.
Okay.
Usually I kind of fill some space and it takes us a second to get a question, so go for it.
Okay. I was just curious. I am a collections manager for a small local history museum. And I was wondering how frequently you should be doing a checksum. Our preservation says every month, but I feel like that is like excessive for how many files we maintain, which is less than 4 terabytes. So I just wanted to get your professional opinion on how frequently we should be doing that. We're trying to do data backups every single month, but just wanted to get your opinion on that.
That's what I was gonna say. It's sort of like a matrix, like a cost benefit analysis, or like a depending on what you have. And it looks like if you do backups every month, I would say you're in pretty good shape. Um, I when I think about, like, I'm just a big uh at work, this is done for me, right? I work at WashU, it's a giant organization. But as far as just my personal stuff, I'm a big hoarder and I'm super nostalgic. So I only do it every year on my stuff. So it is really one of those decisions that you kind of need to make for yourself. I would check out maybe the DPC. If you haven't checked them out, they might have advice for an organization like you.
Thank you.
Susie, do you want to go ahead and unmute and fire away?
Sure. Can everyone hear me?
Mhm.
Yes.
Okay, very good. I'm just wondering about that digital fingerprint that you are using to compare your files to. How subject is that fingerprint itself to rot? Can you trust it every time you use it, or do you also have to run a checksum on that?
I that's a great question. I you know, I feel that question makes me feel like, when you're a fish, everything looks like water. I feel like that's where I am with regard to that question. I have not. I would assume not. I would assume that's kind of built into the program that the checksum takes care of its own fixity for itself. But I applaud you for being so preservation minded. Yeah, if you're out there, if you're going to choose a product to run fixity on your items, I look into that for sure. That would be something you do when you're deciding what to use.
Jenny?
Hello, can you hear me?
Yes.
Yep.
Yeah. Oh, good. Thank you. Yeah, thank you. I'd like to ask about checksums. Sometimes when we run checksums, we might do it on, say, a whole zip file or something like that. So it's like a conglomerate, like one checksum for that whole group of files or individual. I just want to see what you think about that. And my other question is about BagIt. Does BagIt have a means of validating or comparing the initial checksum against the files? Thank you.
Sure. When you say, did you say zip drive or zip file?
Oh, sorry. Is it for, say, a folder or a group of files? Sometimes people in my organization have done a checksum on the whole group of files, but not the individuals.
I see. I see. So
Yeah.
they're zipped while it's been run. What I would do actually, and this kind of gets into answering your second question as well. What I would do is rather than zipping, I would use BagIt, and then BagIt would generate those checksums, and then you could have confidence that all of the files within the bag have had Fixity run on them, which I wouldn't be sure about in a zip file. So those zippers, see if you can get them to do BagIt instead. Um, and uh, as far as your second question, I don't think BagIt has the ability to compare. It runs the Fixity itself, but then I think you'd have to utilize a separate to run the comparison where it will like compare the old versus the new and highlight any that are different where the bits are starting to flip. I don't think BagIt doesn't have that.
Thank you.
Molly, how's it going tonight?
It's good. How are you?
Good.
It's still afternoon here. So I have a question. I work as the solo archivist for a religious organization, and so we had a church close, faithfully complete its ministry, I should say. And for the first time since I've started, they sent a large number of digital files. Given my inexperience with digital archiving, I just had them send it through Dropbox. Is there a, which I doubt does checksums, which would be handy. Is there a software option you recommend?
Well, if they're already sent, um, you, I mean, how many files are we talking about?
Oh, all sorts of like, it's a lot of their more recent administrative files, newsletters, and memorial bulletins. It's a lot, and it was more than I thought there would be because they were a fairly large church.
Mm-hmm.
So that's why I'm like, ooh, this hasn't come up yet, but that would be great to know anything that would save me time because I'm trying to now get them off Dropbox because I don't want to pay for it indefinitely.
Right,
But then
right.
my computer is like, this file name is too long.
Oh my gosh.
But
Yeah,
I'm like, but I don't want to abbreviate that because creator's intent. I might have to, though.
yeah, yeah. Um, I would, I mean, if you can go back to them and get them to use BagIt to resend it, no, that's not an option.
This was on a deadline, I was working with several weeks before the administrative assistant's tenure ended.
I see. Gotcha. In that case, I think I would just do a spot check, like
Okay.
decide to open up one into
Yeah, random files and see what happens.
open up random files and just do sort of like boots on the ground check to see if the files are corrupted or not.
Thank you.
But then you can run Fixity on them for
Yes, no, that's one of my goals. I'm like, that's an easy enough digital preservation technique I can do.
And then you can feel so good afterwards.
Thank you.
Josiah?
Hi, hello.
Hello.
So my question is in regard to using BagIt and for very large content, videos. Would you recommend it for videos? Say, we're having terabytes, some things like 20 terabytes, and trying to segment it out via whatever categories that they're in. Would you recommend BagIt for that kind of content as well?
Oh gosh, I do not have the experience to know for sure. Um, yeah, at WashU we've got folks that handle kind of that larger stuff, so
Yeah.
I just don't know. BagIt hopefully will be able to if you find like a user group. Um, that's the thing about open source, non-proprietary is then often you'll have a lot of user groups where you can try and ask that question
Yeah.
and hopefully get an answer there. So sorry, I don't know.
No worries. Thank you so much.
Gina, you have a very interesting profile photo.
Thanks so much. I'm from a public art program, and so that was from a removal, and it's one of my favorites. Little flying horse. I'm just wondering, and this might be beyond this, um, the kind of scope. So let me know if that's the case. But I'm wondering, what's the next step once you get that kind of flag from the the bitstream of something's gone awry?
Right. So digital preservation, ideally, it's this concept of lots of copies keeps stuff saved. LOCKSS. Um, if you store things online with a service or some kind of server, they will, as part of their service, provide geographical diversity. That's part of what you pay for. So like Google or Apple or Dropbox or any of those people. I work a lot with the Internet Archive, and they also provide geographical diversity. So if a natural disaster takes out the servers in one geographic location, they'll be at another. So for and then bringing it down at like a personal level, I might store stuff in my Google Drive, but also on an external hard drive and in my closet, and also on one. If I was really, really good, I'd also put it on an external hard drive and take it to my mom's house, in case my house burns down. So if you find those bits have flipped, you've got to check your other copies. And 3 is a good number. Often people will have, our services will have 3 geographic locations. You always want to have your 3. So if you find out that 1 bits are starting to flip, you go to your backup and create another so you have 3 good copies again.
Thanks so much.
Okay. I think that's it for our questions. Thank you everybody for sticking around. And this was a good Q&A session. I really appreciate it.
Yeah.
But Sarah will be back we were figuring out if it's OAIS or it's not quite Oasis because we don't have enough letters, but we were discussing that right before we came on. But Sarah will be back in August for that. And then we're gonna put together like a digital bootstrapping webinar later this winter, hopefully, if we get all of our ducks in a row. But thank you so much for joining us tonight. Thanks, everybody.
Thank you.